Hi dear students, welcome to shrisakthikailasshwomensco College, Department of Physics. This is Hausalya, Assistant Professor of Physics. Okay, today we are going to talk about the subject properties of matter and acoustics. Okay, so first of all, this subject or have a 5 units. So unit 1 is elasticity, unit 2 is viscosity, unit 3 is surface tension, unit 4 is waves and oscillations, unit 5 is acoustics and ultrasonics. So this is a 5 units or have the properties of matter. So first of all, unit 1. So what is the topic of unit 1? We are start to elasticity. So elasticity. So in day-to-day life, many applications of there in elasticity. So the springs, elastic rubber bands, elastic cloths, whatever it is the applications of elasticity. Okay. So we are going to syllabus. So this is a syllabus having the topics are bending of beams, expression for bending moment, Young's modulus, theory and experiment, uniform and non-uniform bending, using pin and microscope method, I section girders, cantilevers, depression of the loaded end of cantilever, experimental determination, scale and telescope method, torsion of a body, expression for a couple, per unit twist, work done in twisting a wire, determination of rigidity modulus, static torsion method with scale and telescope, torsional pendulum, rigidity modulus, and movement of inertia. So this is a topic in unit 1, elasticity. So next, what is the concept of elasticity in physics? So we are now about what is the concept of elasticity in physics. So a body can be deformed, that is changed in shape or size by the suitable application of external forces on it. A body is said to be perfectly elastic if it regains its original shape or size when the applied forces are removed. This property of a body to regain its original state or condition on removal of the applied forces is called elasticity. So, what is the concept of elasticity? It means a body can be deformed, that is, changed in shape or size, changed in original shape or original size. It means okay. So, um, if you give a some elastic body, you give a external forces on it, it can be deformed. Then if you lose the external force, or um, if you give an external forces are removed, it can be deformed. Its original shape or original condition is called elasticity. So this property is called elasticity, isn't it? So next, a body which does not tend to regain its original shape or size when even the applied forces are removed is called perfectly plastic body. Okay, so once a body, if you give a external forces, it will transform a new position. Okay, so then if you remove this external force, it can be regain its original shape is called elastic body. If does not regain its original shape is called plastic body, isn't it? Okay, so this is the difference between elastic body and plastic body. Okay. Okay, so it is the concept of elasticity in physics. Okay. So next, Hooke's law. So Hooke's law, what is the Hooke's law? Law of elasticity. Okay, discovered by the English scientist Robert Hooke in 1660. So, which states that for relatively small deformations of an object, the displacement or size of the deformation is directly proportional to the deforming force or load. So, it says the displacement or size of the deformation is directly proportional to the deforming force or load. So, it means if you give an external force some body, it deforming force or load is directly proportional to deforming size. Okay, so the displacement of size is directly proportional to the deforming force or load. So this is a statement of Hooke's law. Okay, so next, what is the Hooke's law example? Okay, so if you well known the Hooke's law, it have an example. A balloon is elastic in nature. Okay, so we are now the balloon is elastic in nature. So when the air molecules are blown in it, it expands. Similarly, when it evacuated, it shrinks in size. Yes. So the expansion and compression of the balloon depend on the force with which the air is pressed into it. Therefore, it works on the basics of Hooke's law. Okay, so this is an example. A balloon is, we are all now a balloon is elastic in nature, isn't it? Okay, so if you fill the air molecules in balloon, it can be expands in nature. Okay, so similarly, when it evacuated, it come to strings. Yes, so this expansion and compression depend on why force. Okay, so this is a basic works on Hooke's law. Okay, so this is an example of Hooke's law. Okay. Finally, what is the application of elasticity in everyday life? So the springs. So the springs are we are all now the springs. Okay. So the base of a trampoline. Trampoline. Why? Because it is elastic nature. Because it is have a elastic body, elastic rubber in the base. Okay. So this is a elasticity example. One of the elasticity example. Next, the bow, the bow to shoot arrows. So shoot arrows is one of the elasticity example. Next, fishing rods. Next, the mattresses, rubber bands, the cloths, and the chewing gum when chewed. After chewed, it is an example of elasticity. Okay, we are all now elastic cloths, fishing rods. Because why? Because the fishing rods are many more elasticity or bending. This is a example of bending. Okay, so this is a bend is one of the application of elasticity. Okay, we are all now the rubber bands, rubber bands, sorry, colored rubber bracelets. Okay, so this is a one of the application of elasticity. So this is a day-to-day life using a small elastic body. Okay, so this is the application of elasticity. Okay. Finally, today we are now about basic knowledge about elasticity. Okay, in next class we are now the next topic. We are going to now the next topic. Thank you.